Hi you guys, this is section 7.1. I wanted to go over a problem where you're asked to describe the sampling distribution of x bar. So here we are, page 345, and I'm looking at question number 23. And the question says, assume that x, that's the population, x is the population random variable, is normally distributed with a mean of 50 and a standard deviation of 10. That's the mean, and that's the standard deviation. Let n equal 25. So that's given. Question 23 reads, describe the sampling distribution of x bar. So this text program is terrible, so I really wanted to write x bar, I just couldn't do it with this text. For n equals 25. Okay, so according to the rules of this section, it says if x is normally distributed, which it is, we know that the random variable x is normal, because we were told so, then that means that x bar, the distribution, the sampling distribution, is also normally distributed. So the mean of x bar, we write mu of x bar, is equal to the mean of the population, these are the rules of the section, which in this case is 50, and the standard deviation of x bar is equal to the standard deviation of the population divided by the square root of n. So in this case, that's going to be 10 divided by the square root of 25. These problems always have very nice population or sample sizes so that you can take the square root easily. So that's 10 divided by 5, which is 2. 2. Am I going to run out of space? 2. So, to answer this question, describe the sampling distribution. You would say x bar is normally distributed with a mean of 50 and a standard deviation of 2. And yes, on your test, you can just write it like that. You don't have to include all this stuff. I feel very compelled to finish it on this side too. Normally distributed with a mean of 50, standard deviation of 2. Balance. Okay, so question number 25. I want to go over 25 also. 25. It says, read along people, without using your calculator, use the symmetry of the normal distribution to calculate the probability that x bar is greater than 52. So they basically they're saying use symmetry to find the probability that x bar is greater than 52. Okay, so here's x bar. This whole curve, let's let that be x bar. So now we're going to say the mean of x bar is equal to 50. 50! And the standard deviation is 2. So each one of these hops is going to be 2. So this is 52, because there's a 2. Over here would be 54. I'm not going to do them all because I only care about 52. So probability that x bar is greater than 52. Oh man, you guys, we're going to have to use that empirical rule. I can just feel it coming. X bar greater than 52. Okay, so I'm going to put a line there. I'm going to go back a standard deviation also. I wanted to warn you guys, there's dogs barking outside. It's going to get loud in a minute. The barking has started. So here's another going back standard deviation. Why am I doing this? Because I'm trying to use the empirical rule. So we want the probability that x bar is greater than 52. So what we want is this yellow area right here. Yellow area right there. That's the probability that x bar is greater than 52. All right, so this is one standard deviation. I'm going to use the empirical rule. Can't make an E. Empirical rule. Empirical. It's easier to say than to write. So we know 68% are within one standard deviation. So 0.68 is within one standard deviation. I can fill that for you to make it look pretty. I'll make it green. Right. Ugh, that green. Sorry guys, that green's a little grosser than I had anticipated. So we know 68% is in the middle, and that leaves 100 minus 68. So you go on your calculator, 100 minus 68, or 1 minus 0.68. That leaves 32% for either side. Okay, so there's 32% divided by both sides. So 32 divided by 2 is equal to 0.16. So there's 0.16 on that side, 0.16 on that side. So the answer is, I'm going to make it a pretty, let's hope that this is a really pretty color, 0.16. So that's the using symmetry to answer that question. Question 25, 0.16. Okay, so again, these all add up to 1, 0.16 plus 0.68 plus 0.16, and I'm using the empirical rule, knowing that's the standard deviation. That one was kind of tricky. Made a mess on my little paint picture.